Hi there, this is Jacob Nash, Precalculus Lessons, and this is a final exam review video. So yeah, at first I didn't know if I was going to do this, but I decided to because it was a lot of different things covered, and but yeah, this will be the last Jacob Nash Precalculus Lessons video, maybe the last Jacob Nash video. I don't know if I'll do any other ones, but anyways. This is kind of like I did an Algebra 2 exam review too, and this is kind of how I did it. It's just like parts, but something to keep in mind is that it's very for the time's sake of the video, obviously it's not going to be super in depth. So if you don't understand something, please watch the specific videos that are on this channel for that certain topic. But this is just a review to like, oh yeah, refresh. Oh yeah, I remember that. And it's not quite everything that you might possibly see on your exam, but it's kind of just some things combined. So just keep that in mind. But for the most part, everything that's talked about on here, if you know it all, then you should be good for any exam. But the first thing is domain. Obviously, there's range too, but range wasn't really talked about a lot in Precalculus because it's not as big of a topic because there's not as much limits to that for what we talk about in here. But domain is for the x, and there are things that limit that. And remember, there's three things that you need to do to find the domain. If you see a radical, set it greater than or equal to 0. If you see a denominator, set it not equal to 0. Sorry, I forgot the 0. And then if you see a logarithm argument, set it greater than 0. That third thing was not mentioned on the original domain video because logarithms weren't gone over yet. But that is something too. So let's look at these 4 different examples. And once again, this might be a little bit laggy because I couldn't record on my iPad, but hopefully not too much. So what do we see? We're looking for that, or a denominator. Which one do we see? We see a denominator. There's no radicals or logarithms, so that's the only thing we have to worry about. And remember what we do, we set it not equal to 0. So technically that's a quadratic inequality, and usually they tell you to graph for that. But in this case, when it's just a difference of squares, you don't really have to do that. But you should do that if it's like a product sum 1. So that, as we know, that would change to this if we factored that. Ugh, stylus kind of messed up. I'll just use the microphone part. Let me see. I might be able to show how it's a microphone part. I can turn on the camera on this thing. Oh yeah, here we go. Microphone. But that's the side that does work. Okay, so then you set both of those things equal to 0, just skipping ahead because I don't know if you saw that red statement, but anything before precalculus will not really be covered on here. It's just assumed that you know it. But if you don't understand some of these things, look at the prerequisite unit. But obviously that would mean x does not equal 5 or negative 5 when you set those equal to 0. And that means those are 2 things that are not in the domain. So the domain of y is negative infinity to negative 5. No, it's going to be kind of hard to write. I'll have to just kind of go on to a different line. Here, I'll just have to write it into this box, this other box, and then I'll have to erase it. But that's what it would be because we're excluding negative 5 and 5. And so, yeah, that's what it is. but I have to erase that because there wasn't enough room for that. So let's do that for now. Now, looking at this one, do we see a denominator? No. Logarithm? No. Radical? Yes. And when you have the radical, you set it greater than or equal to 0. And that's only what's in there. You don't have to have the radical itself in there. So now we would find out that this one's pretty simple. X is greater than or equal to 3. So this is what the domain would be. Sometimes it helps to draw a number line. If it's greater than or equal to, then it's going to be a closed dot because it includes it. Why we had the bracket there. And then to infinity would be like that. All right. That one, luckily I could fit on there. Now, let's look at this. This one's a little bit tricky. Number 3, very tricky actually. And I probably won't have room for this either. Why is it tricky? Because it has all 3. See, a denominator, radical, and a logarithm. So we have to do all 3 things. Logarithm, whatever the argument is, set that greater than 0. Set the denominator not equal to 0. And then set the radical greater than or equal to 0. So that's 3 things, and we need to get x by itself. Here we would have x is greater than 1. The second one, a little trickier. What it would be is you would end up with this, and then you have to square it to get x by itself, don't you? So that would just be x plus 1, then 1, and then that would change to this. See? So it's not as hard as it seems. So that would just mean x is greater than 0. And then this one, x is greater than or equal to -1. So we have 3 things here that all seem weird. So in this case, I would just want to draw a number line. We have -1, 0, 1. We know that x has to be greater than 1. It has to be greater than 0, and it has to be greater than 1. And it includes 1, it doesn't include, oh, it lagged. Sorry. Man, it'll catch up in a second. Hopefully. I just hate this thing. You know, in case you didn't ever hear why I don't use my iPad anymore, it's because it supposedly ran out of storage, even though I deleted everything off of it. I think the only option is to upgrade it. So sorry, Apple, I'm not paying money for that. Man. Yeah, I think it's not something about my computer right now. It's about my iPad because it says it's like loading or something. Well, let me try to just do it on here. I know that I can't draw on my computer because then it freezes for some reason. It like screen goes black. And last time I did that, it turned off the recording. That's just great. Any day now. Maybe if I just like scribble around, it will do something. Okay. Yeah, now it says working offline. Oh, there we go. Okay, so as you could see, let me just change the color so it's easier to tell. It doesn't include 1, it doesn't include 0, it does include 1. How do we know that? Because there is no equal to on this, no equal to on that, but there is on that. Oh, actually, I got that wrong. The -1 is the filled in one and the other ones aren't. So, and it has to be greater than all of those. So that therefore would mean -1 to, not to infinity, sorry, to 0, then 0 to 1, then 1 to infinity. That's a little tricky, but that's how that is sometimes. Okay, now this one is a quadratic inequality because it's not different. It's not a difference of squares, so we can't just do the usual factoring. Because remember, then you get something that doesn't even seem right. Okay, since it's a denominator, sorry, I forgot to slide it over on here. Since this is a denominator or radical, sorry, greater than or equal to 0. Now we draw our graph. And since this is a positive x squared, it points up. Oh, well, let's actually just factor this. That is um 2 and 3, no, 1 and 6. All right, that's how it is. And then so those are our zeros, 1 and 6. And it's going to be a quadratic that points up. Let me just make this red. That points up. And since it has to be greater than 0, where is x greater than 0? All right there. Or sorry, y, not x. Where's y greater than 0? Right there. So that means it's going to be this part and this part. Sometimes it might be that part, but not this time. And so that means the domain is, and always remember to do d of y in case you had a free response one. But 6 to infinity. There you go. That is domain. But sometimes you also have to do domain like this for looking at graphs. So what about these? Here, for this one, what you always do is you think, is there an x value everywhere? If there's not, then that's taken out of the domain. But if there is, then it's all real numbers. Here, it's a blue line all the way across, and we see the arrows. So we know it keeps going on forever. So it's all real numbers or negative infinity to positive infinity. But I'll just say, well, we don't know what it is, like the d of whatever. So let's just say all real numbers. Here, even though you see this hole, which we'll talk about more in a second, because we have this little thing down here, it's still all real numbers. Because if this thing wasn't there, then you would take out this part of the domain. But because that's there, for this x value, there still is a value there. So it's all real numbers. So whole doesn't always mean something's taken out of the domain. Okay. What about this one? We have a vertical asymptote we see here at x equals 1. Well, if there's a vertical asymptote, there's no x value there. So that has to be taken out of domain. So it's negative infinity to negative 1, and then negative 1 to infinity. What about right here? We have 2 jump discontinuities. Well, just like with the holes, right here, since we have a closed-in value, it does exist there, but not there because those are 2 open values. So we don't take negative 2 out of the domain, but we do take 2 out of the domain. So negative infinity to 2, 2 to infinity. That is domain. That was part 1, and that one was a little bit long. And you think that's long, though. See part 3 that we're going to do, because that one's really long. This one's not quite as long. Discontinuities and limits. Remember those things? Those lim, fx. Oh, you might not like that, but let's see. So what are the 3 kinds of discontinuities? Not necessarily the only kinds, but the only kinds we talked about. Holes or removable discontinuity. Sometimes they're called that too, so I put that there. Vertical asymptotes and jump discontinuities. you can see that in depth for the Unit 2 videos, or Unit 1 videos, sorry. So here, this is similar to what I did in that video, except for it's just a little bit more condensed for this time's sake. But we're gonna, for number 9, we're looking at number 9. We're first figuring out the limit and then what kind of discontinuity is. Well, let's go ahead and just know that's a jump discontinuity. Jump discontinuity. Don't know why I put a P there. But remember what these things mean? It's saying as x goes to -2, what does that minus thing mean? From the left. So as x gets to -2 from the left, so coming from over here, so that's a little bit of a confusing thing sometimes, because you're like thinking from the left, that really means you're going to the right, but you just basically just look to the left of -2. Where is the value? Well, that is at 3, because it's basically just saying what value of y is at where x equals -2. And in this case, it's 3. Don't say it's 1. I mean, don't say it's 2. That would be if it's coming from the right. So that's 3. Here, this is a vertical asymptote. And as x goes to 1, well, since there's no plus or minus, that means from both directions. So if both directions don't go to the same thing, it does not exist, remember? But if it does, if both sides go to the same thing, then it does exist. So what does the left do as it goes to -1? It goes to infinity. What does the right do? It goes to infinity. So since both do the same thing, it goes to infinity. If it happened to be like this, or something like this, I don't know how to explain it, but it's not a good example with the vertical asymptote, but there could be situations where it doesn't exist. Number 11. What about this one? And for some reason, there's not an arrow right here. All right, discontinuity is a whole. And at what y value is where it goes to 3 from the right? From the right, so here's 3. The right, that's right there. So what is the y value? 2. See, 2. But also there's ones like this. Remember, piecewise, kind of annoying. So we have to do a lot of different things. And I see an error on here. Fix that. It's supposed to be plus right there. So first we need to know what limit is there as x goes to 3 from the left. So what y value is where x goes to 3 from the left? Well, what we have to do is we plug in 3 to either one of these equations. But how do you know which one? Well, think about it. So you see the inequalities, they tell you. So if we have 3 and it's saying less than or equal to, so that means to the left. And then this one's saying greater than 3. So that's to the right. So that's how we know. This one's to the left, this one's to the right. So this means left, so we have to use this equation. So if we plug in 3 there, -3 times 3, -9, minus 2 is -11. That's the answer. So it's pretty simple, just some things you got to remember. What about to the right? Since this is a plus, that means to the right. So we use this equation. 3 squared minus 7 is 2. What about as x goes to 3? From both sides? Well, look at this. See that? They're different. Each side. So we can actually kind of graph this, and it's can help us. So if we know a point is 3, -11, and that would be a closed dot. And then a point is 3, 2. That we got that from here and here. And then for the closed dot one, the equation is -3x minus 2. And it doesn't have to be exactly right, but we know that's linear, so let's just make it a straight line. And then the other one's a quadratic, and we can just do that. So that's not exactly right, but that's along the lines of what it is. Yeah, let's just fix this, because that's okay. Obviously, they don't go to the same place at 3. So that doesn't exist. Like I was saying it earlier, sometimes that doesn't exist. F of 3, what value is at 3? Whichever one's closed. If there was no closed, you would say it does not exist. But this one's closed, and remember that was at -11. So that's the answer for that. And the discontinuity, that is a jump discontinuity. Remember where there's 2 y's for 1 x? Jump let's say that. All right, that's what that was. All right, now we remember this. We have to name vertical asymptotes, horizontal asymptotes, or holes. Well, I guess it should say and, because in this case, there's all of those. So first thing you got to do is factor it. So I'm not going to review factoring right now, because that's the thing that you should already know. But that would be this up here, and that would be this down here. And remember, vertical asymptotes are if there's something in the denominator that doesn't cancel out with the numerator. Well, there's 2 vertical asymptotes, see? Because there's 2 things lagging again. Sorry. There's 2 things that to see that x plus 4, x minus 4, those are 2 things, and they don't cancel out with the numerator. So actually, there's nothing that cancels out, so there's no holes. I hate this thing. There's 35 questions on this, by the way, so it's going to be a long video, obviously. And if this thing doesn't work, I'm going to be mad. Oh, there we go. And so the vertical asymptotes, you have to set it equal to 0, but that would be at x equals -4 and x equals 4. Remember, don't say vertical asymptote equals -4. Teachers don't like that. Horizontal asymptotes. How do you do that again? Oh yeah, you look at the degrees of the numerator and denominator. So let's look back at this first thing. What's the degree of the numerator? What's the degree mean? It means the highest exponent that there is. Highest exponent is 2, highest exponent is 2. And remember, when they're the same, that means you do the coefficients of the leading terms. Leading term coefficient on the top is 4. 1 is on the bottom. 4 over 1 is 4. So the horizontal asymptote is at y equals 4. So that's just knowing our horizontal asymptote rules, which if you don't remember them, look at the video that is in Unit 1 videos. And there's no holes. And that's not good, because I didn't really think about what this problem was going to end up to be like, but let's review what it would be like if there was holes. Just as a refresher. So we had something like this. Your vertical asymptote would be x equals -4, because that doesn't cancel out. but your whole is, since these cancel out, your whole is going to be, it has an x coordinate of -3, setting that equal to 0. But remember, you find your y coordinate by plugging the x into the simplified version of it. And since those cancel out, the simplified version is 1 over x plus 4. But we plug in -3 for x. And in this case, that would mean that it's -1 for the other coordinate. So that's review of wholes. All right, function features. This is the one that is going to be the longest. If you thought the other ones were long, then this one definitely is. And then luckily, the next one, let me see, was exponential, and then logarithms, and then trigonometry, not as long, really. Okay, so something to remember. This is something that, like, if I were you, I would just, especially just what I'm showing right now, and I will like box it in. Hang on, got it. What I just highlighted or boxed in green, that is something that you're obviously not going to be given, but if you remember it, then it makes things a lot easier. Because remember, this is a little bit, there's a lot of things that are easy to mix up with this. And you don't want to mix it up because that will give you the wrong answer, definitely. And that they know, the test makers know you mix them up, so they'll put the other thing on there, of course. But remember the standard transformation form, x must have a coefficient of 1. Stretches are always fractions, compressions are always whole numbers. So even if you might think that something is a stretch, it might be a compression. I mean, like, I don't know. You'll just see when we get to it. Number 15 especially. And that is the standard transformation form equation. That shows what happens when A or B are negative. And that this shows what all the different things are. So first thing, this is kind of just disregarding what I just said, but let's find the x and y intercepts for number 13. Number 13. Okay, let me write that down. And keep in mind that I'm only doing this for rational equations, or actually that's not a rational equation. But you'll have to know how to do this for any other kind of thing, even if it has a E or a ln or whatever it is. Okay. To find a y-intercept, you set x equal to 0 because in a y-intercept, x always is 0. So to find the x-intercept, or sorry, y-intercept, we do 4 times, yeah, I'm not going to say it, but I'll just write it. And if you noticed, with the rational equations, every time these things cancel out because it's 0 times something. So it ends up always just being the constants anyways. So 12 divided by 16, if you simplify that, is 3/4. So the y-intercept is 0 3/4. Now, the x-intercept is sometimes seems a little bit harder, but you set y equal to 0 and have to solve for x. And you might think, oh, that seems hard, but it's actually not in this case. I mean, really, it seems hard because there's 2 x's and one is on the numerator and denominator. But if you cross multiplied, you would figure out that this multiplies by 0, and anytime something multiplies by 0, it cancels out. So you end up just having this equal to 0. And so then that would be 4x squared equals 12. X squared equals 3. And then the x-intercepts are negative and positive square root of 3. Zero. So that's a little bit harder, but not really that much. All right, this one, this is the kind that I would say that I hate because they make it in the stupidest thing possible. Like, I didn't make this problem. I just screenshotted it from something. And I hate these because every single thing that you could think of is wrong with it, like for it to be in standard transformation form. So remember, that means that we have to change some things. We're going to have to make this 1/3. That's the easy thing. We just make it go over here instead. What's kind of the hard part is what's in here, because remember, x, I already said this, always has to have coefficient of 0. So you have to divide out this. But before you do that, you might want to switch it around. So I'll switch this to this. And then you have to divide this out or factor it out. Oh yeah, don't forget there was -2 right here. So then that would give you, I just hate these because then you have all the reciprocals and dividing out. Okay, so that means we're doing 3/4 right now divided by -3/2. Well, that means multiplying by -2/3, remember? So that would give us -6/12, which is -1/2. So that is the answer for that part, at least. I mean, obviously that's not the transformations. And then, so there you go. Now we have it in standard transformation form. And if you ever think you do it wrong, just multiply back out and see if it ends up being the same thing. Okay, so I will highlight, this is what I've done before. I will highlight all the separate things that are transformations. And of course, in this case, a whole bunch of things are every possible one that there is. I'll just do it. I'm doing it in different colors. What should I do for this one? Red. So, okay, now let's see. So the first thing, which I did in yellow, is a reflection. You might always remember negative means reflection over, and then you might say, oh yeah, was it X or was it Y? Well, for right now, we can just look at this. That is A and that is X. But here's a little trick. Oh, sorry, past it. Something that is outside of the radical or logarithm or whatever the thing is, that is something that always affects the Y. So up and down. And reflecting over the x-axis does that to the y. And so if you think about this, the parent function looks like this, but if you reflect over the x, that does change the y. So then it would look like that. So it's a reflection over x axis. Second thing, that is a vertical meaning y. That's how we know it's vertical, because this 2 is outside of the radical. Vert, I'll just say vert, stretch. How do we know it's a stretch? Because it is greater than 1 and by 2. Sometimes you say by factor of, but I'll just say by 2. Then the next thing, we see the negative that's in blue. That's a reflection over y-axis Yeah, so usually there's not quite this much transformations, but of course there is. Then this is a little bit of a tricky thing. That 3/2, you might say, oh, that means horizontal stretch by a factor of 3/2. But what you always have to do is you always have to flip that over. Anytime there's a horizontal thing, like stretch or compression, it's always the opposite of what you think it is. So if there's anything you pay attention to in this video, this is probably what it is that you should. So instead of what you might think, it's a horizontal, it is a compression of 2/3 or by a factor of 2/3. And then the next two, they're easy. But still the -1/2, you might think negative left, well, actually right. Because anything that's in the radical affects the x, but it's also the opposite of what you think it is. Right 1/2, and then the plus 1/3 means up 1/3. And I'll highlight the things that are opposite of what you might have thought they were, just so you know. And that's what you need to remember. So that's a little bit tricky. Now, here comes something a little bit more easier to remember. Hopefully you do. Find out if it's even or odd. So remember how to do that? You just look at each term and determine if it's even or odd by looking at its exponent. So we have really exponents of 1 there and there. So that's an odd exponent, that's an odd exponent, that's an odd exponent, that's an odd exponent. We have odd divided by odd. And don't think that's odd, that's actually even. Just like if you have a negative divided by a negative, that's a positive. That's even. Even though you might think it's odd, odd divided by odd is even. The only time you have odd as your answer is if it's odd divided by even, or vice versa, if they're different. So if they're the same, even, different, odd. All right, number 17, we really have an exponent of 0 here. Well, not for the 4, technically x to the 0, because x to the 0 is 1 times -4. So it's really like this. But if that's a little bit too confusing for you, then just know that they always have they're always even for the things that have no x. That's also even. Even divided by even, that is even. And over here we have the 4x is odd, that's even, that's odd, that's even. If you have a mix of those, that's going to be neither odd or even anytime it's like that. Okay, so now this is an average rate of change question. And the average rate of change, you are not given the equation for that. So the equation for that is y2 minus y1 over x2 minus x1. Sorry, this is a long video. I'm starting to get a little tired. I always remember delta y over delta x. You've probably taken other classes that use delta, maybe physics or chemistry or principles of engineering that I have videos on, by the way. Or you might just know that delta always means final minus initial. The final one is going to be the one with the higher number, in this case, or the last one. So 2 minus 1, that's always what it is. And I can remember that its rate of change is y over x. So hopefully that's a way that you can remember it. Just always remember that it's 2 minus 1, y over x. Usually you're given the x values. So we have, see the interval is -6 to x and then to -3. But what we really care about is the 6 and -3. Those are our two x's. Since the 3 was given last, that's our x2. And then since the -6 was given first, that's our x1. And you might say, hey, well then what's the y's? Well, that's why they gave you a graph. So where is x3? Here is where x is 3. We go down and the point is 25 for that. So that's our y value. And of freaking course, this thing is lagging. Again. But yeah, there we go. And then -6, it is 5. So those are our two y points. -25, -5. -25 minus -5, that really means plus. That means -20 over, that really means plus 9. So rate of change is -20 over 9. So average rate of change is pretty simple if you just remember it. Okay, here is inverse functions. Whenever you have inverse functions, you switch x and y and then solve for y. Usually these are pretty easy, but I made this one that's hard because just in case you see it, because the other ones you should just know what to do. It's just simple algebra. So this is why they, of course, they put f of x and f -1 of x. That always means inverse. So let's change x and y. So instead we have x here, and then we have this, and then this. And you might say, well, how do you get y by itself? Well, you have to do something that's a little bit crazy. You cross multiply. So you multiply these, and that would give you 5xy plus 2x. And you might be like, xy. Yeah, that seems weird, but that's just what you have to do. And then you have for the multiplying the, sorry, this thing's messed up. Multiplying these, that is just the same thing as it already was. And if we're trying to get y's by itself, how can we do that? Well, the only way we could do it is if we factored it out. So we have to get both y things on the same side. And anything that doesn't have a y on the other side. So we need to move this to this side and the 7 to the other side. So once we did that, that would be 2x minus 7. That's kind of skipping a step, but this is basically just algebra. And then -5y minus 5xy. So we factor out this y here. That would give us, just rearranging our terms, -5x minus 5, and then 2x minus 7. And you divide by this thing to get it by itself, and that is this. Wait a second. Okay, I'm just gonna verify my answer real quick, just to make sure I'm not telling you the wrong thing. But I know that's the right process. I might have made a negative mistake somewhere. How do I know how long this thing's been on? Still recording, isn't it? Okay. I'm using Zoom to record this thing. Of course, the thing that I use to check my answer is not loading. Okay, that was number 28. Not for this, but oh, okay. Wait. That was supposed to be plus. What in the world did I do wrong? The correct answer is actually that. Those are somehow pluses. Where did I do it wrong? Let me just backtrack this thing for a second. Sorry, that's making this even longer. To avoid our negative mistakes, let's just do this. Yeah, put that on that side, and then 7 minus 2x. Then we have plus 5, 2x plus 7. Okay, there we go. This is the answer. All right. Hey, let's play a guessing game. You know what's happening? Lagging again. I am about to like smash this iPad, but at least I didn't pay for it. I won it on a radio contest. Well, that's the answer. Here, I'm gonna do something real quick while we're waiting. Okay. MacGyver punch. Images. I'm talking about the old MacGyver. '80s. Well, apparently it's not a picture of him punching, so I'll just do this. Okay. As you can see, it still hasn't loaded even after I put a picture in there. I put that in there for the next thing. So annoying. There we go. All right, that's the answer. Sorry that took so long. All right, now we're on exponential equations. So I told you that section was long, but these are less long. Okay, so the question says, people who know about MacGyver's punch moves doubles every hour. So the number of people that know about MacGyver's punch moves, that number doubles every hour with 5 people originally knowing about them. How many people know about them in 2 days? So remember the exponential equation? I gotta go quickly because it's starting to get late. As you can see, 9:18. The initial is what A is. So 5 people originally knew about it. Doubles, that means B is 2. And obviously C more review. And so this is our equation, but how many people know about them in 2 days? X is hours. It said that every hour. So X is hours, but it wants 2 days. 2 days is 48 hours. So we need to know that so that we plug in 48 for X. And I know that's going to be a big number. So how many people know about MacGyver's punch moves after 2 days? Approximately 1.4 times 10 to the 15th people, which is a lot of people. Units, people. How long until 517 people know about this, his moves? So instead we plug in Y for 517 or 517 for Y. And then we have to solve for X. We'll divide by this 5. So 2 to the X equals, hang on, 103.4, and changing that to logarithm form, that would be log, yeah, that basically. So we could also, remember the method I showed you in the graphing calculator, you can do math, log, or just a change of log formula, change of base formula, whatever you call it. Either way works. that would mean after 6.7 hours. That's how long it would take, approximately. MacGyver's Swiss Army knife costs $8.79. $8.79 in 1991, but its price increases by 7% every year. What is the cost in 2002? 1991, 2002. That is 11 years. So that's our going to be our X. But the initial amount was $8.79. The base 7% each year. We do percent 1 plus the percent always for that, so it'd be really 1.07, and then we do 11 for X. We plug in 11 for X, so 879 times 1.07 to the 11th power. The cost in 2002 is going to be $18.50. And then it says, what if the price decreased by 13% each year? Still the same initial amount, but instead we have 1 minus that, because it's always 1 plus or 1 minus. And then every 8 years, that changes things. Instead of just X, it's got to be X divided by 8 every 8 years. Remember? Or 1/8 X, either way. But we need to still plug in 11 for X. And that would be 0.87. So we plug in 8.79 times 0.87 to the 11 divided by 8th power. Then if it decreased, then it would be $7.26. So obviously that's a smaller number than 879. So we at least know we did something right. All right, next. Remember, we have to create equations sometimes too by points. And there's a harder version, but I'm not having that on this video, but just know that this is the easier version because it gives you the y-intercept. Y-intercept, that is always the initial value. So 8 is the initial value. But how do we figure out B? Well, if we at least know this much, we can solve for B by using this point. The y value is 24. The x value is 8, so we have to find B. So solving for B, that would mean B to the 8th equals 3, because 24 minus 8 from that. And then that would, we'd change that to log, that's actually not what we would do. We would take the 8th root of 3. The 8th root of 3, which, by the way, you can do by math on the calculator, and then number 5, where it has x of the square root thing. And that means that 1.15 is the base. So the equation for this is this. All right, that was exponentials. Logarithms. We have to solve for x in this problem, and remember we can combine them by multiplying. When it's plus, we multiply them. So we do ln, and then that'll be x times x minus 4 equals ln 21. Whenever you have an ln on both sides, no more ln's. And then that would change to x squared minus 4x, and then equals 21. Solving for x, we would factor, and that would give us x minus 7, x minus 3. That would actually be plus 3, sorry. And then our answers would be x equals -3 and 7. But it's actually only 7. Why? That's going back to domain. You can't have a negative logarithm argument. All right, condense this thing. How do you do that? Well, that's the same thing as what we kind of just did. you multiply them, but remember, whenever you have a coefficient thing, you make that the power of the argument. So 2 to the 4th is what that is. So now we have log of 4 times 2 to the 4th. 4 times 2 to the 4th is 64. So this is log of 6. Log of 64. And then now this one, it didn't have any directions, but we're assuming we need to solve it. We can change that into exponential form. Well, that really doesn't do anything. I mean, I guess it kind of does, but that would just show us that x equals 2, because obviously 8 squared is 64. But well, actually, the another way to do this, in case it was a harder one where you couldn't do it in your head, remember you make both bases the same. That would be 8 squared. Yeah. Okay, trigonometry. All right. This is stuff that I've made videos on kind of recently. First thing, we need to convert that thing to degrees and then find a coterminal angle in between 0 and 360. So the whatever our answer is has to be in between 0 and 360. And how we convert to degrees is multiplying by 180, or we just change pi to 180. So negative 91 times 180 divided by 60 is negative 273. To find a coterminal angle, we add 360. That gives us 87 degrees, and that's in between 0 and 360, so that's good. All right, if cosecant of angle is 47 over 18 and it's in quadrant 1, then what's tangent of angle? Well, cosecant, it's the opposite or reciprocal function of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. And we know it's in quadrant 1, so the hypotenuse is 47. The opposite side is 18. That's the angle. And we need to find tangent. The tangent of an angle is opposite over adjacent. You don't know adjacent, but how do we find it? Pythagorean theorem. And I'm not going to go through that right now, but you would do 47 squared minus 18 squared. That is 1885. Square root of 1885 is, for time's sake, we'll just round 43.4. And we just used Pythagorean theorem, which was this, but that's pretty much something you already know, so hopefully that makes sense. So that is our adjacent. So tangent of an angle equals, that tangent of an angle is 18 over 43.4. There we go. What is the secant of that? 2 pi over 3. 2 pi over 3, well, we know that by our unit circle that is in quadrant 2, and anytime something has a denominator 3 that has 60-degree angle, this doesn't make sense to you, please watch the video specifically on this. And so we go to quadrant 2, we make a triangle, we make it have 60 degrees. We know that across from 60-degree angle is, oh my gosh, what in the world? Mine just went blank. I don't know what I'm doing. Mine just went blank. I don't even know. I'm just really tired. Across from a 60-degree angle is, I just don't want to say the wrong thing. And I was about to say something with pi, of course. Sorry. Square root of 3 over 2. Jacob Nash has failed you today. And then that we would know this is 30 degrees. Across from a 30-degree angle is a 1/2. And how do we know those are negative? Because y and x are always negative in quadrant 3. In quadrant 3, dang it. That's it's supposed to be quadrant 2. Sorry. Messed up something else. Okay. Let's redo that. That's positive. This still is negative. All right. Secant. Secant is the opposite of cosine. Cosine is adjacent over hypotenuse. So instead it's hypotenuse over adjacent. And so the hypotenuse is 1 because it always is for a unit circle. And then the adjacent is 1/2, 1 over 1/2. It's really multiplying by 2, so it's -2. Right? Terminal, whatever. We have that point, and we need to find the angle. Basically, I'm not going to say that. I don't feel like. So x is -14, y is -3. And we're trying to find this angle. Well, we know that would mean this is the adjacent and this is the opposite. So we do know that the tangent of the angle equals -3 over -14, which is really just 3/14. And you do the tan of the negative first to find the angle. The tan to the negative first over 3/14 is 12. I'll just round to 12 degrees. That's not your answer because it's in quadrant 3. So obviously that's not what it is. So we add 180 to it. And that will give you 192. That's a key thing you need to remember. I'll just highlight that. That's not the answer because that would be a quadrant 1 angle. All right, 2 more things, 2 more problems. Simplifying the one thing. All right, sine squared x. And then the cotangent, that is x over y. So cosine over sine. Just make that fractions. So these would somewhat cancel out and give you sine x and cosine x on the top over cosine x. Cosine x's cancel out, so you only have sine x. And that is the correct answer. All right, next one. This one's a complicated one. A pretty complicated one, sort of. But we can change. Actually, it's not really that complicated. Well, that was a simplifying one. This is a solving one. And sine by our Pythagorean identities, we know is the same as that. So if we get everything on the same side, the ones would cancel out. And so you can factor out a cosine x. So you have cosine x minus 1 or plus 1. Wait. Yes, minus 1. So that would give you cosine x equals 0 because the negative would just go away divided by 0. And this is cosine x equals 1. And cosine is x. So where is x1? I mean, where is x 0? X is 0. I'll just write my points here. Ugh, come on, this thing. All right. Cosine. So cosine is x. So cosine 0, that would mean where x is 0. X is 0 here. That's the wrong point. That's 0, 1. Oh my gosh, this stupid stylus, I'm about to smash it. It takes so long to write. Okay, so here and here, and the angles there are pi over 2, 3 pi over 2. And where x is 1, x is only 1 there because it's negative in the other place. That's 1 or 0. That's your answers for that. So sorry that the last part was kind of just rushed, but if you didn't understand something, just watch a specific video about it. But thank you for watching this long video, and good luck on your exam. And that'll be it for Jacob Nash Precalculus lessons. Thanks for watching.